Well, hey there, Math 9. We're going to move into our next installment, next thing that we have to talk about in math, and we're going to look at exponents. So that's Chapter 3 in Math Links 9, and we'll get going on that right away. Lesson 3.1 is a pretty quick topic. Your objectives are the following. When we're talking about exponents, we're really describing repeated multiplication, and we want to describe what these things are called powers. So you might have heard of 5 to the second power. What does that mean? Comes up in this lesson, we'll get right into it. So few things, a few quid pro quos that you should know, little bits. You've got powers and bases, and they make up your exponent. So in this case, you're looking at 4 squared. I'm just going to rewrite that. You've got 4, and then you've got this funny looking number that goes up in the air like this. So little anatomy lesson. What do we have here? What is this in its exponential form? This little doodad here is known as the base. And this right here is what we refer to as the power. There we go. So 4 written this way is in its exponential form. It's a lot easier to write 4 squared than it is to write it in full form, which is equal to 4 times 4. Exponential form is just a really neat mathematical form of shorthand. You could imagine if I said 4 to the 1,000,000th power, how sore your hand would be by the time you were done writing 4 times 4 times 4 1,000,000 times. So in our examples, you could get some very large values that can be represented quite easily. So as I say, it's just shorthand. Switch up colors here. Let's go with a blue. So the power is how many times something's being multiplied by itself. 6 is being multiplied by itself twice, so you say the power is 2. 4 is being multiplied by itself 3 times. Now be careful, that I'm not saying 4 times 3, I'm saying 4 to the third power. 4 times 4 times 4. This is 9 to the 5th power, and this is 2 to the 1, 2, 3, 4, 5, 6, 6th power. By evaluate, that's a fancy word which means just tell me what the answer is. 6 times 6 equals 36. 4 to the third power is 64. 9 to the 5th power I will leave to you. I don't have those ones memorized. But 2 to the power of 6, that is one we could deal with pretty quick. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. There you go. Okay, switch up colors again. It's important to identify the anatomy of an exponent. Like, what do you have? Well, this is 5 to the third. And you probably have the experience to write these. 5 multiplied by itself 3 times. You've probably seen that before. In this case, it's 1 being multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. And this is 305. What's weird about 305 is it's sitting by itself. It's not being multiplied by itself more than once. So when you see it like that, you say, well, the base has to be 305. If you don't know what the exponent is, make it a 1. It's just 305 once on its own little lonesome there. Just like if this had just been a 5 all alone, it would have been 5 to the first power. But 5 wasn't alone. 5 was being multiplied 3 times in our first example. The base will work backwards. This one was a 5, this one was a 1, and this was 305. The understood power, since you couldn't see one here, first power, seventh power, and third power. The power is this number which is higher than the base. It's kind of like the Statue of Liberty. The Statue of Liberty holds up the torch, right? It's very separate, it's very distinct. The power is very distinct. It's held up in the air. And if you've ever used Microsoft Word, if you ever go to put in a power, you have to go and choose the superscript function, meaning it's super, it's above the average level or height of the words. What your assignment or your introductory notes try to get you to do here is to see that exponential notation is just repeated multiplying. Like this. Try to write small. 10 to the 6th power is quite a few tens. You see why we start to use scientific notation. Just because we start running out of space. Evaluate is a word, for some reason, becomes a bit of an issue. It just means figure out what 2 to the 5th evaluates to. What does it mean? 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 3 to the 4th power. A little trick is I can identify what looks like a 9 times a 9. That's a neat little trick I like to use. 81. And this will be, when I see the ones being multiplied by each other, that's fine. How many zeros do I have? 1, 2, 3, 4, 5, 6. A number with 6 zeros? 1,000,000. And I'll use the comma just to separate the decimal places there, the thousands and the millions from the hundred thousands, just so you can see it easier. 16, and 2 times 2 is 4, and there's 2 zeros in here. Little trick. 400. Scroll up a little bit. The base itself could be positive or negative. There is a very interesting little Bedmas trick here, and this can often turn out to be an issue, but I'm going to clarify it now. You see that this is in parentheses. This is -2. And this -2 in parentheses, what they're trying to indicate to you, they're being very clear that it's -2 is the base. From our work with integers, when negative numbers are multiplied, they cancel out. Here's a hint. If you see a negative base and you see an even numbered exponent, you can rest assured that it will be a positive result, because the negatives will cancel out. Negative times a negative equals a positive. So I'll just nuke these, because that's largely what happens. The negatives cancel out, and you're left with 2 to the 4th. It's like you're multiplying 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. When we look at some of these examples below, first thing you might notice here is there's no parentheses on example B. So I have to show this very clearly. This minus sign means the negative of 2 to the 4th power. zoom out now so we don't miss that. In BEDMAS, the term of is like multiplication. Now that's very sneaky, because what the result is you think of 2 to the 4th which gives you 16, but it's the negative of the answer. That, because that negative isn't inside the parentheses, it is BEDMAS. So think of it this way: the negative of this. That gives you negative 16. That's sneaky. You have to watch out for that. And I tell my students, unless it's the negative value is in parentheses, it's not a negative base. If you look at C here, you can see that it is in parentheses. They're being very proper in their identification of this number. Negative 4 times negative 4 times negative 4. Because there's an odd number of multiplications, these negatives would cancel out, but then you would have a positive 16 being multiplied by, oh, guess what? A negative 4. Positive 16 times negative 4. I'll move this over a little bit. Which equals negative 64. Again, you notice a pattern. If the base is negative and the exponent is odd, there would be an odd number of multiplications, so the negative will win out. When you look below at the next example, let's choose a different color. Let's go with blue just to switch things up. This is the negative. Let's be consistent here. Negative of 4 times 4 times 4. So specifically what you've got is a BEDMAS question where you're taking the negative of. That is the equivalent of multiplying whatever the answer is by negative 1. You have to do the exponents first, so you do this part first. Pencil tool, there we go. You have to do this first because that is the exponent part of BEDMAS. So you must do the exponent part, and then the negative of, believe it or not, is multiplication. Because the word of means times. Negative times the answer. The answer is negative of 64, leaving us with a minus 64 result. In question or example 4E, it can look a little bit confusing. Go to BEDMAS and notice that you have to do your exponent first. This has been well identified in parentheses, so you know exactly what you're multiplying with. And if you're not entirely sure, this is negative 6 multiplied by itself 3 times. See if I can just zoom out. It's never a problem if you don't know what it is. Negative 6 times negative 6 is 36 times 6. This is never a problem. 18, 21, 216. And then it's just scribbled it on paper. It really doesn't matter. You can always erase it. Your answer is 216, and sure, these first two negatives would cancel out, but then that very last negative right here, this little doodad here, is the final negative, and your answer is negative. Quickly, we'll just go through F pretty fast. The parentheses indicate what's going on. Because this exponent is even, these negative signs will of course cancel out, so I'm highlighting them. But you've got to keep your eye on what's going on in the question, because what they've done in fine form is they've taken the negative of doing all of this. And that is very frustrating. So this is the negative of essentially 36 times 36. So you could take the negative of your answer and put it right in there. And I don't have 36 times 36 memorized, folks, but I'll let you crank out that answer. So in the beginning, what we give you is a bunch of repeated multiplication to see if you can identify the exponential form. The fact that this example gives you the base in parentheses strongly states that this is -3, and we're sure of it, so we'll put in parentheses, to the 4th power. Now -3 times -3 is 9, and we have another -3 times -3, which is another 9. Well, 9 times 9 is 81. That's a way of thinking about it. -2 to the 5th power, because I see that the power is odd, I automatically know the answer is going to be negative. An odd exponent with a negative base is going to give you a negative answer. What I like to do is I know the answer is going to be negative, so I just look at the 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I already knew the answer was going to be negative, so I just write a 32 with the negative in front. -6 to the 5th power. Notice that it's inside of parentheses. This is -6 times -6 times -6 times -6. Holy smokes, times -6. Running out of room. This one you can do with your calculator, and I'll show you a neat way to do that in just a minute. -125. It had to come from, well, what 3 things when multiplied, they have to be exactly the same, give you 125. A hint lies in the 5. When I see a number that ends in 5, I think, oh, it's probably going to have come from a multiple of 5. And you, as you work through your 5 times tables, you think 5 times 1, 5 times 2, 5 times 3. 5s are the kind of things that you multiply with that'll give you numbers like this. Switch colors. 125. Well, go through combinations that you know. You know it won't be 2 times 2 times 2. What about 3 times 3 times 3? No, that won't work. 4 times 4 times 4, no, that's 64. 5 times 5 times 5, that works, 125. If it doesn't come to you right away, just go through the first couple numbers that sort of pop into mind that are still kind of small enough. Now, if this is 5 times 5 times 5, the answer is negative. So putting parentheses around these really clarifies that you are multiplying with an exact base of -5. This is -5 to the 3rd power. There we go. Let's highlight that. base -5, third power. Your assignment is down here. It's at the bottom of your notes pack. And I'll just show you something on my calculator function here. I think I have just enough time to do it. So I'll hop out of our notes here. And I have a calculator on here. Calculator Pro. Kind of fancy. Neat little application. I got it for free. And on your calculator, you'll have buttons roughly equivalent to this. So 6 squared gives you 36. Let me clear that. Interesting, when I hit the 6 button and then I hit this to the power of 2 button there, I'll hold it down for a second, how some of these calculators will show that. Pay that no attention, just look at your result, 36. If I wanted to do -6 to the third power, there we go. I would hit this button which says x to the y, or on some it will say y to the x. And what it's asking me is, what power did you have in mind? Okay, let's say it's to the third power. There we go, -216. So again, on your calculator, if our base were -5, and I took it to whatever power I wanted, I hit this button, which gives me manual control, and then I just say the power is the third power, -125. On some of the calculators, in this one in particular, you see that error. I had to fill in a little bit more of the information, -5, and then it wanted me to put the parentheses around it just to be 100% sure of what I was talking about. I could take this to the 5th power and show you that you get a negative result. So this has been an introductory lesson to exponents and using exponential form. There you go. Hope you enjoyed it. Have a good one.